Hi, this is Mrs. Slater, and today we're just going to go over the Chapter 12 review that you have at the end of your packet. So go ahead and get that out, and we'll start with number 1. Number 1, write in exponential form. Because the 11 is going to be as a base, that's what we're going to start with. So it'd be 11, and then 14 is going to be the exponent, and then it's going to equal b. For the next one, 2 is the base, so now it's going to be a larger font here in exponential form, to the z equals x minus 4. Now we're doing the opposite, so now the 7 is going to be the base, which is going to be a subscript of log to the 2004-01 equals the exponent. Same here. The base 5 is now going to be a little base 5. 47 is going to be right beside that, and 3x. Now we're going to graph and identify each of the following. So what we are going to base everything off of is the parent graph. And a parent graph of this function is going to be y equals 4 to the x. This is just symbolizing a shift to the left, and this is going to be symbolizing a shift up. So then we'll show with the XY charts. So if I did an XY chart and plugged in several values for x, I'm going to use 1, 0, 1, and 2, where anything to 0 power is 1, 4 to the first power, and then 4 squared is 16. Okay, now I'm going to use those exact same values, but instead of, for the shift, we're going to go ahead and subtract 2 from all of those values, and we're going to add 1 to the y values. Remember, we always have to do opposite of what the x is telling us in the original equation. So our values would be -2 and 1. 1 minus 2 is going to be a -1, and 2 minus 2 is going to be 0. Okay, now for the y values, 1 plus 1 is 2, 4 plus 1 is 5, and 16 plus 1 is 17. So it doesn't look like the last point is going to hit the graph, but we'll do our best to guess. So this XY chart goes with this equation. So -2, comma 2 would be here. -1, comma 5 is going to be up here. And 0, 17 would be way, way up here. Okay, now because it shifts up 1, the boundary in which it gets closer and closer to is also going to shift up 1, because it usually gets closer and closer to 0 without crossing over it. So that's a little messy, but you get farther and farther to the right anyway. And let me go ahead and fix that, and then we'll go on. Okay, so the domain are all the x values from left to right, and it's going to the left, -infinity, and then it's also going to the right forever, so it's going to be a positive infinity. The range is how far down, which as we were just talking about, it's not going past this line right here, so it would be getting closer and closer to 1 without crossing over it. So we would put 1, and I didn't mean a -1, I know, let me erase that, too confusing. Okay, so then we have 1 comma infinity, because it goes on forever up. Okay, the intercepts are just where it crosses the x-axis. Well, it's not going to cross the x-axis, but the y-axis we have right here at 0, comma 17, and that is considered the y-intercept. The asymptotes is something we haven't covered, so you do not have to worry about that. Let's go on to the next one. This is a natural log, so we are again going to relate it to the parent graph, natural log of x. Go ahead and get an XY chart set up, and I'm going to only use 2 points this time. The 2 points I want to use are 1 and e. Okay, if I plug a 1 in place of the x, keep in mind that e would be right there, even though it's invisible. E to the what power gives you 1? Always 0. E, natural log, base e of e, remember when those are the same, it's going to be 1. So I have 2 points to graph. So now when I do the shift, which this again means shifting to the left, but this time 1, so we're going to subtract 1 to both of these values. So 1 minus 1 is 0, and the y value is going to remain the same. E minus 1 is this, and the y value is going to remain the same. So let's go ahead and plot the first one, and then you will need your calculator to find the value of the next. So go ahead and get that out, please. So now that you have your calculator out, let's go ahead and find the value of E minus 1. E is the second button, and it's right above the division, and then minus 1. And we'll get the approximate value of 1.17. So 1.17 is the value here. So I'm going to go over 1.7 and up 1. And my log will go to the left, so my boundary also moves to the left. It usually got closer and closer to the y-axis without crossing over it, but now, since it shifted 1, it's going to get closer and closer to -1, which leads us to domain. So it's going to go to -1 without actually crossing over it, and it goes to infinity to the right. The range, it goes forever all the way down, and then also up forever. The intercepts, you can see, are at 0, 0, and that would be it. And the asymptotes you do not have to do. The next two I want to simplify a little bit. For the first one, log base x of 5y over 2, and number 8, simply just get rid of the 5 that's on the bottom. So it would be natural log of 2x to the third. Okay, so number 7, you can see in the problem where there's multiplication and division. So in those two cases, the multiplication, we're going to have to expand it into addition, and the division is going to be subtraction. Okay, so the first move I would make is to say that log of x of 5, and then again multiplication becomes addition, so it'd be log of x of y, and then finally the subtraction, so it'd be log of x of 2. Okay, on number 8, there is an exponent. So as we know, an exponent is going to have to go down in front. So it's going to be 3 natural log of 2x. Now, we are not finished because of that multiplication has to be transferred into addition. So the 3 is going to be attached to all of it. So it'd be 3 and then natural log of 2 plus natural log of x. And that about does that. I also want to simplify 9 and 10 before we even begin. So go ahead and cross out the first parts of both of them. Okay? And with the single logarithm, we do the opposite of 7 and 8. When we see addition, we're going to then multiply the two values together. And if we see subtraction, we're going to then divide them. And the only other thing left would be if you see a product, like the 7 in the example below, you are going to make it an exponent. So those are things to be aware of. All right, so then you'll see that 5 is number in front, so that's going to be now an exponent. So we'd have log of base b of 2 to the 5th, and then the plus sign means multiplication with the 3. And as you can see, we can simplify that a little bit because 2 to the 5th power is 32, and 32 times 3 looks like it's 96. So you can simplify in those places. And that is supposed to be a 6 right there. Okay, the next one, again, we have a number in front, so that's going to go back as an exponent. So you'd have log of z minus 2 to the 7th minus log of x. And then the only thing left is the division sign, because that subtraction is going to lead us to that. Now there is no base, so that's just going to be an invisible 10. And then all over x. So that all goes in one single logarithm. 11 through 13 we did not go over, so you can skip those 3. Let's go ahead and go to the next ones. And whenever you have a exponential form, you want to change it to log form. So it would be log of 4. I made the 4 too big. So it'd be log of 4 of 256 equals 2x. Now go ahead and get the calculator out again. We'll put this in change of base form. which would be log of 256 over log of 4, and it'd be, and final answer, make sure you close your parentheses, divided by log of 4, and you get 4. So the value of 4 equals 2x, so therefore x equals 2. Okay? On this one, you want to simplify as much as you can first. So you want to divide both sides by 3. And again, the calculator will help us find out what the value of that is. Divided by 3. So we end up with 5.7. I'm going to go ahead and estimate. So that'd be 5.786. 5.786. And then, as we know about exponents, they're going to go down in front. So it'd be 2 times natural log of x equals 5.786. And then by dividing by 2, I'm getting natural log of x all by itself, which is good. We want to get to where there's just a single logarithm on one side. So I'm going to take that and divide it by 2 using all of the numbers above so I can get a more exact answer. So I end up with 2.89. And now it is in log form, so I can just take e, because there's an invisible e anytime you have natural log, to the 2.9889, I'm sorry. And now back to the calculator one more time, because second ln will give you the exponent all ready to go. And I'm going to do second answer, so I can use all the number from above and push enter. And the final answer is 18.05. Okay, so that's what I would put in the answer blank. Okay, let's go on to the next one. 16, you would want to go ahead and simplify as much as possible by multiplying 2 to both sides. And now you can just change it into exponential form. X to the 8 equals 29. And then we haven't seen this in, I don't think ever, but you would take the 8th root, just like if there's a 3 or 4, whatever that number is, you would take the root of that. And your calculator helps you with that really nice, because if you go to math, and then you go down to where it has the 5th one, where it has x, whoops, something happened there, so let's try again. Math, and it would be number 5, so maybe that would be the best way to go. And then put the 29 inside, and then arrow back to get that changed to an 8. And there you have it. That should work now, because it's 8 through 29, and you get 1.52. Alright, so the next one, we have a lot of logarithms going on. So you can simplify by making it a single logarithm, and addition means multiplication, so I'm going to multiply those two together. And we have the exact same base on both sides, so if we can multiply both sides by log, we definitely can divide both sides by log. So we're left with x squared minus 2x equals x plus 4. Now, if you get everything to one side, you end up with x squared minus 3x minus 4, and now it factors. And also, we want to use the zero product property, and negative ones do not work with this particular log, so that is out. So x is only going to equal 4. The next problems I'm going to work through and then show you snapshots of each so you can get the answer when you're studying at home. Push pause and check your answer. Push pause and check your answer. And I notice on this one, with monthly, we haven't done that much this chapter, so I'm going to cross that out. But the continuously, you have done, so push pause and put that answer in your notebook. (21), solve. And you would have to do the quadratic formula at the end. And the last one, you can omit. That will not be on the test. This concludes the review. We'll do some more tomorrow in class.